Okay, great. So my name is Arman Sultantono, and for the next few minutes, I will be presenting on building your own content delivery network, or CDN, based on NGINX and NGINX Plus. So on the slide here, you'll see a lot of, you'll see the most popular CDN providers, Akamai, Cloudflare, Limelight, Fastly, and so on. And it's no big secret that these CDN providers use NGINX under the hood. In fact, you'll find a lot of public blog posts and technical articles about how these CDN providers leverage NGINX and how they use it in their CDN offering. So how does a CDN work? So a CDN is essentially a collection of cache proxies, often called POPs in the context of a CDN, or points of presence. They're essentially caching servers in data centers spread around the world. And the idea is a CDN proxy or a CDN server minimizes the distance between the visitors and the origin website, so that if you were to load a web page and web page resources, rather than loading, downloading all that content from the origin servers, you can download it closer from a CDN POP. So most websites tend to operate on a larger scale with large target audiences scattered around the country or globally, which makes CDN a really popular use case for advertising, media entertainment, online gaming, e-commerce, mobile, healthcare, even government and education. So if you take a look at this diagram here, without a CDN, every time a user makes a request for some web content, they're routed through multiple hops throughout the internet and download that content from the origin server, and then download that content back to the client device. Whereas if you were a client that was downloading that content through a CDN, content delivery network, they typically download that content from the nearest CDN server, making that round trip much shorter. So what exactly is the problem with a commercial CDN service? Typically, one CDN sort of does not fit all use cases. They're very limited in customization. You don't have the ability to configure a CDN to the granularity that you need for a high performance, for maximum security and reliability. And often you're simply presented with a GUI, some buttons and text fields, and so customization is very, very limited. The administration side, you are a slave to the SLA as well. If you want to purge the cache, for example, you might have to put a ticket or a request, and you might have your content purged anywhere between 5 minutes to 4 hours. And so in many cases, with today's agile development and the need to be really agile and pushing out changes, that latency from when you want to make a change to when it actually happens, it can be too long. And I think the most common feedback that we hear from our customers, who are also CDN customers, is that commercial CDNs are very, very expensive. You are charged by throughput, by connections, by bandwidth, the features that you add on, and as your business grows, as that traffic increases, your costs can get out of hand very quickly. So what components make up a CDN? As mentioned before, CDN is a collection of CDN servers scattered around the world. To bind that all together, you do need to have a reliable backbone network with intelligent global routing, so that when a user makes a request, that request lands on the nearest servers, and that the networks that connect the CDN servers together and back to the origin servers are reliable. If you are streaming content such as video, there will be software sort of solutions there built into the CDN to encode content. There will be administration tools to upload content, delete content, purge content, and there'll be tools for monitoring. So there's quite an ecosystem of solutions that that collectively create a CDN. So the big question, really here is, and we challenge you in thinking this is, why pay for a CDN service when you can build your own? So we know that NGINX is a very popular and reliable, battle-tested solution that a lot of um, CDN networks are built on. And so, why not build it yourself? And so, one of our large customers, who I can't name who the customer is, they actually replaced Akamai, their CDN provider, with an NGINX Plus based CDN service that they stood up by themselves and run and operate by themselves independently. And in doing so, they saved over $4 million in the first year. I think the most important savings for them was to not be bound to contractual agreements about, ceilings and overages in terms of bandwidth usage, since they can't really forecast an accurate number of bandwidth that they may need during an important product release or during the holiday season. They typically were dinged and paying overages whenever they exceeded their bandwidth in their contract. And so with building their own CDN based on NGINX Plus, they didn't lose any performance because NGINX Plus is known to be and proven to be, in their case, a high performance caching proxy solution, and they were able to save money by not paying overages and other costs associated with running a CDN on someone else's network. Netflix is another use case where they're using NGINX as part of their CDN offering. So obviously Netflix is a giant, and a large portion of internet traffic in the world and nationally here in the US is actually attributed to Netflix. And being a large content provider, they saw it as much more beneficial in terms of cost savings, agility, and also performance by running their own CDN network that is based on NGINX. So if NGINX, so if Netflix is using NGINX, that's really just validation of big players on the internet can rely on NGINX in providing high performance, secure, and reliable CDN service. So I want to go into more of a technical deep dive now of how a CDN solution performs with NGINX Plus and how it can be implemented. So if we go back to, just at a high level again of how NGINX is typically used. NGINX is typically used as a web server. The open source product of NGINX runs over, NGINX open source and NGINX Plus runs over 300 million websites on the internet, and over 60% of the top 10,000 websites run on NGINX. And NGINX Plus specifically, adds on a lot of features to bring NGINX to be an enterprise ADC. So load balancing, web application firewall, and a lot of features around live activity monitoring and so on. So NGINX as a CDN essentially is expanding that NGINX footprint to the edge. When we say the edge, it means to a point of presence closer to the end user. So in our case, NGINX is deployed all around the world, wherever you can. So with NGINX and NGINX Plus, it can essentially be installed anywhere that Linux can be deployed, which means your CDN solution based on NGINX could be based on your preferred cloud provider, or even a multi-cloud provider type architecture. So NGINX can be deployed on Azure, AWS, Google Cloud, DigitalOcean, essentially anywhere that Linux can be installed. And the only other essential piece in binding this all together is pairing this with some sort of GSLB service or global server load balancing solution. So most DNS providers will provide this as a service, and most cloud providers as well. So AWS, for example, has Route 53, where you can configure some heuristics and rules to say, if a user is making a request from a particular geography, then send that request to the closest NGINX instance up on their cloud or anywhere. So as an example, I created, I built my own CDN based on NGINX Plus, just as a proof of concept. And at a high level, it looks something like this. So I have my NGINX Plus origin servers in San Francisco. And I have my origin servers serving my web applications, my test web applications, and I've also deployed NGINX Plus cache nodes around the world. So in this example, I've went for a very sort of cheap solution just to demonstrate how easy it is to deploy this, and I used DigitalOcean using their $5 small-sized instances. So I have an NGINX Plus cache node in New York, in the UK, in India, and also in Singapore. Those are all the availability zones available to me in DigitalOcean. And to help manage and monitor my fleet of NGINX instances, I've also deployed an NGINX controller, which allows me to give me visibility to all my NGINX instances scattered around the globe. So I also used web page test to verify, to validate my test results. Loading NGINX via a cache proxy versus loading the website directly from the origin. And so, as you can see in my test results, the further the client is from the origin server, the more significant or greater the reduction in load times are between loading that web page directly to the origin, which is in San Francisco, or via the CDN POP, which is closer to the client. So if I were to open one of these results here, for example, I can load the web page test result here, and we can see sort of the characteristics of the web page. So for example here, a web browser in Singapore, Chrome, using a native connection, loading my test website, which is located in San Francisco, took over 16 seconds to load, as you can see. This waterfall diagram here really illustrates what that timeline looks like loading that web page. So my web page has over 500 web page objects. So that's 500 different pieces of content on my web page, which could be images, could be style sheets, could be JavaScript, could be anything really. And 500 web page objects is really within the norm these days. For example, if you were to open your developer tools on your desktop and you were to have a look how many pieces of content are on some of the more popular websites on the internet, like Amazon.com or maybe CNN.com or BBC.com, you'd see well over 500 web page objects. So really 500 web page objects is within the norm, or could even be argued as a lighter website these days. And why I'm highlighting the point of web page objects is it's because web page objects plus latency equates to the total load time. So the more objects you have on the page, it means the more round trips that a web browser needs to make to request and download an object from the origin server. And the further you are, the longer that round trip is, the greater the latency is. And that's why loading a web page in Singapore is 16 seconds as opposed to loading a web page in New York is 7 seconds. But if I was to compare the result to loading the web page to a local nearby NGINX cache proxy, which I'm showing in this case here, you can see that the load time dramatically drops down to under 3 seconds. We're still downloading 500 web page objects. It's still the same size of 1.2 megabytes. It's just simply less latency. So those 500 round trips are a lot shorter and equates to lesser total time to download the entire web page. A really good analogy is like, you're trying to bake a cake and you're downloading, you're trying to bake a cake and you need to collect all the individual pieces that are on that ingredients list, but you need to go get it one at a time. And so it's like driving to your supermarket, driving back home, going back to the supermarket, buying another item, driving back home, and so on, and doing that as many times as you need to complete that ingredients list. Whereas a cache, a CDN could be seen as you just taking a walk down to the corner store, which is a far less distance in terms of a round trip, and so that you can collect all those bits and pieces much faster. So now I'm just going to go through some of the configurations that are required to deploy a CDN service. And these slides here just sort of briefly go over some of the important NGINX directives that make this happen. So first of all, obviously you need to have a web server. This could be anything. In this case, it's just an NGINX origin server that's just serving static web pages. And what I want to highlight here, which is important, is that I am setting the cache control. So in this case here, I have a location block which essentially sets a cache header to the maximum amount of time, and it makes the cache control public, so that any objects any image objects here that are downloaded will have that cache control slapped on as a HTTP header. And this makes these images cacheable to the web browser and also any downstream cache proxies, such as a CDN node. On the cache proxy side, we need to set up the proxy cache, and here you'll see some typical proxy cache directives, such as where in the file system I'm storing the cached objects, what does the folder structure look like, what is the maximum size of my cache, and also what is my cache key. So in this case here, we'll be caching unique objects based on the scheme, so HTTP or HTTPS, the proxy host, and also the request URL. And then we could use all sorts of different variables here to define a unique piece of content. That could be, user agent, it could be cookie, it could be any sort of information that NGINX can read. And down at this slide here just basically shows a more granular view of my proxy cache settings. So in this case here, I'm saying that anything that's a 200, 301, 302 is cacheable and is valid for 7 days. I have this in a location block with a regex match for the CSS and JavaScript JS extension. So these rules apply for these file types. And as you can see here, I'm overriding the cache headers. So NGINX has the ability to ignore cache headers, and so that it can set this cache headers itself. So that's very important. For example, if you have an application team that's designed a website but it's not cacheable by default, then you could create a CDN network that would and a configuration that would ignore the non-cacheability of that application and make it cacheable by ignoring it and setting cache headers within NGINX. Another really great feature in NGINX is the ability to do byte range caching. So this feature, really in a nutshell, means that you can cache slices or small segments of an overall file as opposed to the large file itself. So, the application or the use case of this would typically be large media content, such as PDFs, or even more commonly would be streaming or large videos. So again, rather than downloading the entire 5 GB movie, you can start downloading small segments of that 5 GB movie and smaller chunks, since those smaller chunks are cacheable closer to you. So that helps with performance and also increases, the a better user experience. NGINX Plus also has some really great features that help the reliability of your application as well. So in this case here, using active health checks is very important, because we also want to ensure the origin servers that are behind the cache nodes are up and reliable, and so that if a cache proxy needs to make a request to the origin server to collect an updated or a new piece of content, it can do so, and it can make that request to a server that is actually alive and up and not down and unperformant. So active health checks is a feature in NGINX Plus. And in terms of synchronizing the configuration, so obviously this will be an administration challenge, since you are dealing with a large fleet of NGINX Plus instances to configure, right? So anytime you want to make a configuration change, a challenge would be, how do I update my 10 cache nodes scattered around the world? So first of all, NGINX makes itself very open and very easy to configure using your own tools. So you're more than welcome to use your own DevOps tools, your own configuration management tools, whether it's Ansible, Puppet Chef, or whatever you are using. Or you could use a little script that we make available as well. It's called NGINX, which allows you to make a configuration change on a master node or a single NGINX instance and have that configuration replicate out to the other NGINX Plus instances in your cluster, first by doing configuration and syntax checks, doing configuration snapshots so you can roll back if something happens. But this is just one tool that we make available for you that makes building a CDN possible and managing very easily. An important feature that we have in NGINX Plus is the cache purge API. Obviously, this is a very important feature for managing cache proxies, especially a CDN network or a network of cache proxies. This allows you to make an API call to purge the cache. So, for example, if you wanted to push out a new version of your website or a new piece of content, whether it's a logo or a PDF file, you have the ability to completely purge or blow out the cache entirely for an application, or selectively choose which files that you would like to purge from the cache. And so NGINX Plus has an API which makes that very easy. As you can see here in this example, I'm just doing a curl call, and I can purge all the files in my CSS directory with one API call. And the second example I have down there is purging just a single file, which is the favicon. So, how do you propagate a cache purge API call to all your NGINX Plus instances? Again, you could use your own configuration management tools to do that. One built-in feature that we have in the NGINX product is called the mirror, which allows you to mirror requests. So you could leverage this feature as well, which means that you can make an API purge call to a single NGINX instance and have that mirrored out and propagated to all your other NGINX Plus instances as well. So that's just an overview of the DIY CDN, do-it-yourself CDN based on NGINX Plus. NGINX Plus is highly configurable. There are hundreds of directives and tuning and um, tuning options, and so I mean obviously we didn't cover it all, but here are some bullet points on some other um, sort of you know features or items you could also build in or incorporate in your CDN network. One's building high availability clusters within each availability zone. So rather than having one CDN node, say in New York, you could have 2 or 3. So that's a high availability cluster right there. We have really great blog posts around automating or integrating NGINX in a CI/CD pipeline. So this gives you some good ideas on how to manage a CDN in a very automated and a fail-proof way. NGINX supports HTTP2, and so you could easily enable that in your CDN network as well. Even upscale your HTTP 1.1 origin servers by fronting it with an HTTP2 enabled NGINX cluster. SSL offloading and optimizations that could help with performance. You could definitely bake that into your CDN configuration. Same with our many different security controls, rate limiting, connection limiting, IP blacklists. And also a WAF as well. So you'll be able to integrate a WAF into your CDN network, and that could help not only provide high performance and reliability, but also add a layer of security. So just as a summary, just comparing the benefits of NGINX CDN solution, doing it yourself versus a managed service, is that you aren't tied to the service provider's SLA. You get to determine your own SLA. You get to be as agile as you want to be. There aren't any limitations into sort of administration or configuration, since you have the ability to go into the NGINX configuration and really tweak it as granular as you need to meet your business needs. NGINX is very lightweight. It's battle tested. It's high performance. As mentioned, even the large CDN providers use NGINX under the hood. So there's really no question whether NGINX is suited for the job or not. We definitely are. And NGINX is just a very mature product, and it has a lot of features baked into the product. We have a lot of third-party modules that you can integrate with NGINX, meaning that you can do a lot more than just caching. You can add a layer of security on it as well, just as an example. Cool. And just to round things off, I just want to also show you the NGINX controller. So the NGINX controller, I've used it in this CDN use case to basically provide me a central management portal where I can view all my NGINX instances scattered around the world and really monitor its performance. So NGINX control is really great for a build your own CDN solution. It's very easy to add in NGINX instance into this dashboard by just running a small lightweight agent on the NGINX host, and it will show up here on the left. As you can see here on the left, I have my NGINX nodes that are scattered around the world. It just goes to show that latency is not an issue for the controller product here. I am able to view my my graphs and the health of my instance in India, for example, which is a latency of 150 milliseconds where I'm sitting. And the tagging system makes it very easy to filter and view a subset of my CDN as well. Whether I want to just view the nodes in America or Asia or Europe, I can do that very nicely and easily using the tagging system. But what's really great about this product and how I'm using the controller for this use case is primarily for the monitoring. So for example, here I have a custom dashboard, which I've picked out out of the 170 plus different metrics that I could choose from to create a dashboard to have a global view of my CDN. So in this case here, I'm really just taking a look and comparing, cache hit versus cache miss, the bypass, what items have expired, and just by looking at this dashboard, I can quickly see that in the last week, the health status of my CDN is green and well. As you can see here, I'm seeing all 200s. I'm not seeing any redirects or 400s or 500s, and I'm seeing that the disk space versus free versus used is very healthy. There's a healthy a delta between what's used and what's available. I can also clone this graph and just have it, sort of presenting a local view. So here I'm just taking a look at my CDN in New York. So looking at the same statistics, but looking at a view where I'm just looking at a one particular region. The last two features that are very beneficial for this use case is, one is the analyzer, being able to do an audit of my configuration. As I tweak my CDN cache proxies, I can look back here and see, am I still following best practices? Do I have any vulnerabilities? And are any of my SSL certificates up for expiry? And two, I can use the controller here to create alerts as well. So I can create an alert to say, for example, if I have any 500s, one 500 in the last 2 minutes in any of my NGINX instances in my CDN tag here, then go ahead and send me an alert email. So this is really great from an ops standpoint. And to be honest, this is, this here brings the NGINX build your own solution almost, close to par to what you get from a GUI standpoint from commercial CDN providers. So very useful tool for this use case. So that's all I have to show for this presentation. And I'll end it here. And